We're going to talk about transformations for basic sine and cosine graphs, or we're going to talk about how that changes the properties of the graphs. So let's refresh your memory. The period of the graph is how long it takes before we start repeating ourselves. So I could take this little S shape here that's kind of hard to see and highlight, and I would repeat it over and over and over again if I wanted to make a stamp, and I could make a sine graph. So from 0 to 2 pi, I just keep repeating that little shape over and over and over again, and that's my period. It's 2 pi width. Amplitude is from the center of your wave to the highest or lowest point, and my amplitude of a basic sine graph is 1. Same idea for cosine. If I wanted to draw a cosine graph, I would just use this little curvy V, and I would just repeat it over and over and over again. That curvy V is the width of from 0 to 2 pi. That's my period. And amplitude from the center of my wave to the highest or lowest point, the height there kind of is 1. That's my amplitude. So these are basic sine and cosine graphs. Just there's nothing multiplied in front or added to the end or anything like that. But, of course, we can't keep things that easy. We are going to do transformations. We've done transformations with other functions, so now let's do them with sine and cosine. Okay, luckily, you don't have to go through and tell me vertical stretch and shrink and left and right and all that kind of stuff. You just need to tell me how it affects the graph, what's happening to the amplitude, what's happening to the period, and what's happening to the phase shift, meaning does it move left and right. Well, what are the formulas that we're going to need here? Amplitude talks about height. So if you remember back when we talked about transformations here, this piece here, the A piece here, changes the height, the vertical stretch and shrink. So amplitude, I don't care if my graph gets flipped upside down or anything, so I'm going to put it in absolute values. So the height of my graph, the absolute value of A, tells me what's happening to the amplitude. Is it getting taller or shorter? Period is kind of, I've been using the word width interchangeably kind of. So the period or the width of my graph, remember B changes the width. My basic period is normally 2 pi for sine and cosine. So now if I divide it by whatever my B value is, that'll tell me my new period. And because period is a width or a distance, we need it in absolute values because we can't have a negative width or distance. So again, 2 pi is a normal period for sine and cosine. We're going to divide it by B to get our new period. And last, the phase shift. We never did anything with a B and C value in this class before, but now I am going to give you some that have B and C values. So we can't just straight up say the C value is what changes it to the left or to the right. It's the C value over the B value. And we're going to put a negative here. Sometimes people have negatives up in these original equations, so they put a positive here, but that requires you to think through in your mind and make it backwards in your mind. So we're going to just say, look at your equation straightforward, and we're going to change the sign of C and put it over B to get my phase shift. And this one can be negative or positive because we're talking about left versus right. Those are two different directions. Two things I want to mention. If you don't have any A, B, C, or D values, the A's are implied to be times 1 because our amplitude is normally 1. The B's are implied to be 1 because 2 pi over 1 is still 2 pi and our period is normally 2 pi. And C and D plus C or plus D is implied to be 0. I'm not adding anything, so I'm not moving left or right, 0 phase shift. And the D value tells you if you're moving up or down. I guess I should mention that because I do ask you about D values sometimes, but that's just your vertical shift. And one last thing is a lot of times you will see an X here instead of a theta. I don't know which one I'll use, but that's just because people like to use Y equals X values. All right, let's do some examples. What am I going to have you do? Determine the amplitude, period, and phase shift for these graphs. So as long as you remember these, what are they called, formulas here, we're golden. Well, as long as you remember the formulas and know how to deal with fractions and stuff, we're golden. And you know how to do that, so we're going to be great. Okay, determine the amplitude, period, and phase shift of y equals 1/4 cosine of 2x plus 1. See, I used an x there instead of a theta. All right, I'm going to pick out what my A, B, I don't have a C value, so that's plus 0, and D values are. Amplitude is the absolute value of A. So my amplitude here is the absolute value of 1/4, which means my amplitude is just 1/4. So instead of being 1, now it's a lot shorter. It's only 1/4. Period is the absolute value of 2 pi over b, because 2 pi is my normal cosine period, and now my b value is 2, so I'm cutting my period in half. All right, well, 2 pi over 2, if I simplify this fraction, the 2's cancel, and the absolute value of pi is just pi. So my period is now cut in half. And phase shift, am I moving left or right at all? All right, negative c over b. Phase shift. Negative c over b. Well, c is 0 and b is 2. So 0 over 2 is just 0. So there's no phase shift. It's just going to stay in its normal cosine position, but now it's not as tall and it's been squished in. Here's a picture of what the graph would look like. In a future video, we will be graphing these by hand. Woohoo! But for now, I'm just going to show you the graph. All right, let's do another example. Same exact thing. All right, let's find the amplitude, period, and the phase shift. So the amplitude, let's figure out our A value, B value. Again, my plus C is 0, and there's my D value. Reminder, D just moves the graph up or down. So this graph was moved up 1, and this graph will be moved down 1. Okay, A, there's nothing there. So my amplitude doesn't change. That does not mean that my amplitude is 0, because my amplitude is never 0. Then I wouldn't have a sine graph at all. That just means my amplitude didn't change. There's generally a 1 there. If you don't, oh, you can't see that. There's normally a 1 there for A and B if you don't see any numbers. So my amplitude doesn't change. It stays a normal 1. And even though there's a negative there, amplitude's an absolute value because I just care about height. So it's just 1. All right, period. 2 pi over b. This is where you have to get good at keep, change, flip, or dealing with fractions. It's an absolute value, but honestly that doesn't matter because we have positive numbers here anyhow. So I'm going to write it as top divided by bottom. Top divided by bottom. I like to have double fractions so it's super clear what's going on. And we're going to keep the first fraction as is, change division to multiplying, and flip the bottom fraction, or the 1/4. Keep, change, flip. Multiply across the top, multiply across the bottom, so my period is now 8 pi. Whew, it used to be 2 pi and now it's 8 pi, so it's like way wide. And then phase shift again is pretty boring. Negative c over b, well, c is 0, so I don't have to even do keep, change, flip here because there's no phase shift. Here's what your graph would look like. We will do these by hand next class. All right, let's do the next one. Cosine. Y equals cosine of x minus 4. All right, there's no a value here, or it's implied to be a 1. There's no b value here. It's implied to be a 1. How do I know if this is c or d? If there are no parentheses, this is a d value. All right, amplitude, there's no number in front of my cosine, so my amplitude is going to stay a normal 1. There is no number in front of my x, so my period is going to stay a normal 2 pi, because 2 pi over 1 is still 2 pi. Oh, well, this one is super boring. And phase shift, negative c over b, well, c is 0, so I guess I just showed you this so you could see the difference between d and c if there's no parentheses. All right, let's finally do one with a phase shift so you can see how we calculate it. It's not weird at all, just so you can see it. All right, amplitude is still going to stay our general 1 because there's no number in front. Period is 2 pi over 6 in absolute values, which is pi thirds. So it got shorter. Phase shift is negative c over b. So negative 3 over 6. Phase shift is negative 1/2, which means I took this graph and moved it backwards a half. It's really hard to see because we count in terms of pies and not just straightforward numbers. So on the graph, it's not necessarily going to look like we moved it backwards a half, but we did. Just know that we did. Take my word for it. In this case, the signs refer to the correct direction. So negative is in the negative direction to the left, positive is to the positive direction to the right. Let's do something with a little bit cooler of a phase shift. You may not think it's cool, but I do. There's no A value again, so amplitude is 1. Period is 2 pi over negative 1/2, but we're in absolute values, so the sign doesn't matter. I have double fractions again, so I'm going to do top divided by bottom. I dropped my negative sign because we are in absolute value. And I'm going to write over 1 because I like to see double fractions. Keep, change, flip means my period is now 4 pi. And then if I do my phase shift, negative c over b, negative 3 pi over 4 over negative 1/2. Double negatives cancel out. That's purely just because double negatives not absolute value or anything here. And if I do top divided by bottom, I can do keep, change, flip. I'm going to go in and simplify that 2 and 4. And then this will be 3 pi over 2, which means I moved it to the right, 3 pi over 2. You could have multiplied and made it 6 pi over 4 and then simplified to 3 pi over 2. You'll just have to work through fractions. All right, one last example. Finally, we have an interesting amplitude. There's a 3 here, a negative 3, but amplitude is just talking about height, absolute value. So my amplitude is 3. Period, we have a 4 there, so absolute value of 2 pi over 4 means that it is just pi halves. And then phase shift is negative pi, negative, because it's negative c, and this is c, all of this is c, over b. Oh, and I don't have to do anything cool. So, or, fine. So this is just pi fourths to the right, and there's your graph.